This is a video designed to help you prepare for an assessment about wireless power from space. So if you're trying to work through these ideas, this is the video you want to watch, but we're not actually going to be doing the work on this sheet because this is where you're going to show your own mastery of the ideas. Instead, we're going to use a similar situation that is more familiar to what we've seen in class. And if you're looking for this document that I'm looking at right now, you definitely want to follow along with your own copy of this document if possible. And you can find that by going to this link and use it to print out a copy. So if you just type in all lowercase bit.ly/micver and then the number 0, you can get a copy of this. So we can see this is a problem about, or this is a situation involving a microwave, and there are 2 light bulbs in the microwave and a jug of water in between. Not asking questions about whether this is a safe setup or not, but we do have some evidence or some data about some different materials that would be relevant to the problem, including air, this jug of water, the light bulbs, and then perhaps some reflecting material. So it says, imagine that you place 2 light bulbs in a microwave with a large plastic jug of water in between. In the diagram, you can see this setup, specifically a magnetron, which produces microwaves from an antenna, and 2 light bulbs, which glow while receiving microwaves. So let's look at the first question. It says, imagine the magnetron directs energy along 2 straight line paths toward the light bulb. These straight line paths are shown by the dotted lines. And the first question is asking, which bulb would absorb the most energy and glow brightest? Explain, referring to specific evidence. We can use a number of things as evidence here. We know from our experiments in class that water does absorb microwave radiation. And we know that the bulbs glow if they receive and absorb microwave radiation. And we have some information in the table that's relevant to that. So we want to think, for these 2 paths, how are the microwaves going to interact with the material that's in between the magnetron and the bulb? We can tell from the table that the jug of water is going to absorb 100% of the microwaves. So that's actually very relevant to the question of like whether bulb 1 will light up, whereas there is only air between the magnetron and bulb 2. So an example of a good answer could be the water absorbs 100% of the energy between, I'm just going to write BTW, the magnetron and bulb 1. Bulb 2 gets more microwave energy because air only absorbs, and then I'm going to go back to the table and say, okay, the air absorbs 5%. And then a good way to end this answer would be, therefore, bulb 2 bulb 2 glows brightest. So I'm showing you an example of a nice complete answer. This is a good time to say, however, that if you're really trying to get as much as you can out of this video, writing the answer down may not be enough. You want to be thinking actively about whether this answer makes sense to you and maybe even try writing this in your own words. I'll give you an example of what that looks like here. So in the second question, we can say, what matter interactions in the system could cause a difference in the amount of energy transferred between the magnetron and the bulbs? Again, explain, referring to specific evidence. The difference between question B and question A here is this part. This is specifically asking about matter interactions. And this is only asking about us about energy. So this table is not going to be enough evidence to answer this question. In order to really answer this question well, we need to refer to details of how the matter is going to interact specifically with the microwaves. We know that 100% of the microwaves absorb into the jug of water, but a good question to ask ourselves would be, what happens to the particles of water when they absorb that energy? We've seen some examples of what happens when particles absorb energy, and we've seen some examples of particles absorbing specifically microwave radiation energy. So I'm going to start my answer by writing, when the water particles and I know that I'm referring to matter because I'm referring to particles, absorb energy. And then I'm not actually going to finish this sentence for you right now. Your job is, and don't write down what I'm about to write down, I'm just telling you what you should do. Your job is to explain what happens to the particles. You can tell us the particles move faster because heating up means the particles move faster. Or you could tell us that the energy has to go somewhere into the particles and it makes sense for them to go into heating them up, or specifically, like I said, moving them faster. But you want to be very specific about the matter interactions in your answer here. If you're only talking about energy, you won't be answering the whole question.